Hello everyone. How are you doing today? There are 3 laws of motion that we are familiar with. Today, we will discuss Newton's first law of motion. Newton's first law will tell you 2 things. A body or an object at rest tends to remain at rest, and a body or an object in motion tends to remain in motion at a constant velocity, unless acted on by a net external force. The tendency of the object to resist changes in a state of motion is called inertia. Thus, Newton's first law of motion is also known as the law of inertia. The important point here is that if there is no net force due to unbalanced forces acting on an object, the object maintains a constant velocity. If the velocity is 0, the object is said to be at rest. If an additional external force is applied to the object, its velocity changes because of that external force. Here's a wheel that's resting on the ground. Because there is no net force acting on the wheel, it remains at rest. According to Newton's first law, a net external force is required for a body to move or change its velocity or direction. Therefore, when a body is stated to be at rest, it indicates it is not subjected to a net external force or an unbalanced force. A body is in a uniform motion, acted upon by an unbalanced force, changes its acceleration. As previously stated, an unbalanced force acting on a moving object could make the object change its direction and speed, and stop moving. The acceleration of the wheel, which is moving uniformly, increased due to the unbalanced force acting on it. Let us try to understand Newton's first law with a moving aircraft. An aircraft in flight is a good example of Newton's first law of motion. 3 major forces are acting on aircraft: lift, weight, thrust, and drag. Weight is the force caused by gravity. Lift is the force that holds an aircraft in the air. Thrust is a force that moves an aircraft in the direction of the motion. Drag is the force that acts opposite to the direction of the motion. When flying at a constant airspeed, the thrust of the aircraft perfectly balances the drag. This indicates the first part of Newton's first law. As the aircraft experiences no net force and travels in a straight line at a constant airspeed, what happens when the pilot changes the thrust of the aircraft engine? When the thrust is increased, the aircraft accelerates and the velocity increases because the thrust and drag are no longer balanced. The second portion of Newton's first law is that a net external force changes the velocity of the object. As the velocity increases, the drag also increases. When the increased drag equals the new thrust level, the forces balance out again, and the acceleration stops. The aircraft maintains a new constant velocity which is greater than the initial velocity. Now we are back again to the first part of the law, with the aircraft traveling at a constant velocity. Throughout our talk, we've come across the term unbalanced force. So, what exactly is an unbalanced force? When a force is unbalanced, the net force, or resultant force, is not 0. Look at the example of tug of war, in which each team is trying to drag the other across a center line. As in the first case, if both teams exert equal force on the rope, the net force acting on the rope is 0, and the rope remains stationary. Otherwise, as seen in the second case, the rope will move to one of the sides, where the pull is more. If the force is unbalanced, there will be acceleration. 2 factors influence the rate of acceleration: the net force on an object, and the mass of that object. If the net force is less will be the acceleration. If the net force is more will be the acceleration. Therefore, acceleration is directly proportional to net force, F. Now let us see the relationship between mass of an object and acceleration. Could you say which one will accelerate more for the same net force of 50 units? Bus or van? Of course, the van. Right? Since the mass of the bus is more than that of van. For the same force F, the van will accelerate more. Hence it can be said, the more the mass of the object, lesser the acceleration, The lesser the mass of the object, more the acceleration. Therefore, the acceleration is inversely proportional to the mass of the object. Newton's second law describes the effective net force and mass upon the acceleration of an object, often expressed as the equation of acceleration, A equals F over m. This we will see in Newton's second law. Next time, we'll look at Newton's second and third laws of motion. Thank you very much.